Welcome to the ultimate one-shot revision of chapter Motion and Time, Class 7 Science NCERT. Whether you are preparing for CBSE exams, NEET, JEE or even IAS, this video gives you a clear and complete overview of the chapter packed with simple explanation and real-life examples. Hello dear students, this is Dr. Aamarpali Roy and I am thrilled to welcome you to this exciting learning session brought to you by Sojanya International Educational Foundation. This journey of education and exploration has been deeply inspired by my beloved mother and teacher Srimati Sneh Lata ji, whose vision and commitment to nurturing young minds continue to drive our mission, making learning fun, accessible and meaningful for every student. So, grab your notebook, stay curious and get ready to explore the wonderful world of motion and time. Motion is how things change their position. When we measure motion using distance and time, we unlock the basics of all physics. Types of motion. There are many ways things can move. Linear motion, moving in a straight line. Circular motion, like the hands of a clock. Oscillatory motion, to and fro like a swing. Periodic motion, repeating at equal intervals. A car covers more distance in less time than a bicycle. That's because it is faster. Speed tells us how fast or slow something moves. The more distance an object covers in less time, the faster it is. That's the magic of speed. Formula of speed. Speed is equal to distance divided by time. Distance is measured in meters and time in seconds. Measurement of time. We use time every day to cook, to catch buses, to play sports. History. Before clocks, people used smart tools to tell time. The sundial used shadows. The water clocks dripped steadily. And hourglass counted seconds with sand. In the 18th century, Maharaja Jai Singh II built live Jantar Mantar observatories in India. The Jaipur Observatory has the world's largest stone sundial, Samrat Yantra, standing 27 meters tall and accurate to within 2 seconds. These amazing tools show how advanced India was in astronomy and timekeeping even before modern science. From classic analog clocks to smartwatches, we now track time with just a glance. Stopwatches and smartphones helps us measure every second, quick and precise. Stopwatches help us measure motion and speed with precision second by second. They turn science experiments into hands-on learning adventures. Simple pendulum and oscillations. A simple pendulum is a string with a metal bob. When it swings once back and forth, that's one oscillation. Time period is time taken for one oscillation. The time it takes is called the time period. The table shows time taken for 20 oscillations. From this, we can calculate time taken for one oscillation. Experiments. Try this at home. Use a toy car, a ruler and a stopwatch. Measure the time it takes to move 5 meters. Use the formula. Speed is equal to distance by time. Compare your speed with friends. How fast do you walk to school? Measure the distance and time, then compare with your friends. Who is the fastest walker or cyclist? Different living things move at very different speeds. For example, a rocket zooms through space at 8 kilometers per second, while a tortoise crawls at just 8 centimeters per second. To compare how much faster the rocket is, we must convert both speeds to same unit. Here is trick. To convert kilometer per hour to meter per seconds, multiply by 5 over 18. This simple formula helps us understand speed more accurately. Speeds of living organisms vary widely from the slow crawl of a snail to the rapid flight of a hummingbird. Here I am showing you Cartesian coordinate graph. The coordinate plane has two main lines. The horizontal line is called the x-axis and it goes left and right. The vertical line is called the y-axis and it goes up and down. Where these two lines cross is called the origin at point 0, 0. A distance time graph is a graphical way to understand how objects move. On this graph, the x-axis represents time, the y-axis shows distance. Why use graphs? They help us visualize motion and detect whether it's uniform or not. A speedometer shows how fast a vehicle is moving right now. When you are driving on the highway and want to know your current speed. An odometer, on the other hand, keeps track of the total distance the vehicle has traveled since it was new, helping you to know when to get maintenance or check your mileage. Paheli noted the odometer reading of her bus every 30 minutes during a school picnic. This helped her track the total distance and allowed the class to calculate the bus speed. Bojo asked how far they had traveled by 9:45 a.m. To answer this, their teacher introduced a concept of distance time graph. A distance time graph helps us understand how distance changes with time. On the x-axis, we have time marked in equal intervals 8, 8:30, 9, 9:30, 10. On the y-axis, we have distance values 0, 20, 40, 60 and 80 units. To plot the points, mark 8 with 0, 8:30 with 20, 9 with 40, 9:30 with 60 and 10 with 80 on the graph. The straight line connecting these points shows uniform motion where distance increases steadily over time. The slope of the graph tells us about speed. The steeper the line, the faster the speed. Types of distance time graph. Graphs help us see motion. A straight line is uniform motion. A curved line is changing speed. Horizontal line is stationary object. Bar graphs in motion studies. A bar graph uses rectangular bars to show data visually. For example, if we can display the runs scored in each over during a cricket match, the taller the bar, the bigger the score. This pie chart shows the dry composition of Earth's atmosphere. It highlights that the nitrogen makes 78%, oxygen accounts for 21%, argon is 0.93% and carbon dioxide is small but important 0.04%. This line graph shows how a man's weight changes with age. On the x-axis, we have age in years and on the y-axis, weight in kilograms. The graph illustrates a steady increase in weight during early years, followed by plateau in the middle age. After 60 years, there is a slight decline in weight. To calculate the slope of distance-time graph, use the formula slope equals change in distance divided by change in time. This slope represents the speed of the object. A steeper slope means higher speed, while a flatter slope means slower speed. Spellings. Here are some important spellings to remember. Write them down minimum 5 times and spell them loudly while writing. On your screen, suggested diagrams and graphs are mentioned. Learn the formulas as well and make sure to practice drawing and labeling these diagrams and graphs carefully. Pause and check your understanding. Let's test your memory. Pause the video now and try these questions. Once you have answered, compare your responses with mine. Ready? Let's see how well you did. Practice writing these answers in your notebook. It will help you remember better. You can also comment below if you want answers to NCERT questions. Great job today. Remember to read your NCERT book, ask questions and practice regularly. If you'd like solutions or worksheets, just drop a comment below. Until next time, keep moving forward and keep learning. Feel free to share your doubts or questions in the comments. And don't forget to subscribe for the next chapter. Thank you.